And I suppose I should have something on the board for you here. Is it turning on? Here you go. Okay. All right. So when we look at sampling and hi, are you here for AP Stats?
No, I'm just gonna sit in here. Oh, that's my sister.
Oh, well, welcome. What grade are you in?
I'm a sophomore.
You're sophomore now. Carly can have you, promote you to be into AP Stats when you get older. All right, so just a couple things will make this real informal, but let's just go through a couple of these terms, and if there's anything that pops up that you want me to go through, I'm going to kind of say my spiel. But their key concept: studies and surveys observe, experiments use control and apply a treatment. Now, one thing that I would write down in my laundry list on the side here. So I'm on the second slide. No, I'm not. I'm on the fourth slide, it looks like. Okay. For your laundry list, the only way that you can prove causation is through a well-designed experiment. And a well-designed experiment includes control, randomization, using enough subjects, and being blind if possible. Okay? Randomization, control, using enough subjects, which is also known as replication, okay? And being blind if possible. So I'm kind of looking at this fourth slide right now, and I'm just adding to it. I'm not going to read it word for word. And this will also be on my YouTube channel if you want to watch it more, or if you need to write kind of just around the margins. Now, I want to talk specifically right now about a simplified random sample versus a stratified random sample, a cluster sample, a systematic sample, and then a convenience sample. In my class, I talk a lot about the Hunger Games. Okay, you guys remember me talking about the Hunger Games, those of you in my class? Hopefully, yes, no, maybe so. Okay, so the big thing is the difference between a simple random sample and a stratified random sample, or a block and then a completely randomized sample. Okay, a stratified random sample and a block are very similar. They're both the Hunger Games effect. So if you think about the Hunger Games, we had a hat with the boys, we have a hat with the girls. We pull out one boy and one girl to go to the Hunger Games. Now, what's the difference between a stratified random sample versus a block? If you're doing the Hunger Games example, if it was a stratified random sample, I'm doing some kind of study. It's just like an observation. I may be asking you what college you're going to or what teacher you prefer, and I'm looking at boys versus girls, okay? Or what's your favorite pizza? And why do we do a stratified random sample? We do this so we can get a really a representative sample. So for example, if you think about it in terms of you guys, if I wanted to ask the whole school and I wanted to figure out their favorite kind of pizza, okay? Or if they want, like, what kind of pizza they like. So I'm going to ask them that question. And I decide I want to sample 100 people. So instead of, right, that seems like reasonable, 100 people. And I want to say, what's your favorite type of pizza? And let's just pretend 82% of them say they love cheese. This is a simple random sample. Is it possible with n equals to 100 that I could get mostly upperclassmen there? Yes. So what I could do then is I could do a stratified random sample instead. I could have now, instead of 2 hats like the Hunger Games, I could have 4 hats. I could have a hat with the 9th graders, and I could interview 25 of them. A hat with the 10th graders, and I could interview 25, and so on and so forth. Now, what's an advantage here? The advantage of the stratified sample is you're getting a more representative, or the overall sample is more representative of the population. Okay, are there any questions that are popping up? Yeah, Danny.
Would that still be considered a random sample, even though you're choosing who you want to interview?
It is still random because I'm putting all of the 9th graders in the hats, all of the 10th graders in the hat, so on and so forth. The difference is, and I've seen this a lot on a multiple choice question, is what differentiates the two. And yeah, you could say, well, the Hunger Games or whatever, but the statistical definition of what differentiates these is in an SRS, there's all chances, or every chance, right, of size N. What do I mean by that? If I have 1,000 kids in the school, I could have Danny, Eric, and Carly, okay? If I'm doing boys and girls, which would be a stratified random sample, there's no way I could get a sample of all boys or all girls. So for example, here in my whole school one with the pizza, there's a chance I could get all seniors, right? There's a chance, it's not that great, but there's a chance that the 100 people I pull out of the hat are all seniors. Where over here at the stratified sample, there's no way I could get all seniors in a sample because I have it set up for 9th graders, 10th graders, 11th graders, and 12th graders will for sure be part of the sample. Do you have questions about that? Was I clear? So there's every kind of combination of sample size 100. Every combination is possible here if I have a total school of 1,000. We're over here, the total school of 1,000, right? I'm going to have 100 people, no matter what. I've deemed that because I'm going to do 25, 25. But there's no way I could have a sample of size 100 of all 9th graders. There's no way I could have a sample of size of 100 of 9th and 10th graders only. We're over in the SRS, I could. Does that make sense? Yeah, Carly? Okay, so that's a good question. The difference between stratified and the block then would just be in the block, we're doing an actual experiment. Okay, so in a block, usually a block is set up something about gender, or I've seen them about animals. So like big dogs compared to small dogs might respond to medicine differently. Girls and boys, there's a reason there's a multivitamin for a woman, okay? Right? And then there's a multivitamin for a man. They respond to things differently. So with a block versus a completely randomized sample, a block is going to take the boys and the girls, and then it's going to run the experiment twice. So the boys will get the experiment. There will be random assignment. Okay, they take a simple random sample and say, hey, 50 go here, 50 go here. They get treatment 1, they get treatment 2. Okay, and then it happens again with the girls. N is equal to 50 here. This is group 1. And then group 2, N is equal to 50. Okay, they get treatment 1, they get treatment 2, and then we analyze the results. Okay, I got to plug in because I just got a little beep. Now, what would be the reasoning to do a block versus completely random? Right, so like if you, hold on here, let me just plug this in. So in a completely randomized, okay, you would just have the total population or right? Or the total sample. I have 100 people. I break them up into groups. Group 1, group 2. N is equal to 50. N is equal to 50. Treatment 1, treatment 2. And then look at the response. Now, is there a chance in this one, right? Same kind of thinking. Is there a chance, like treatment 1 could win significantly? We go through the test, we find a p-value that's very small, and we have evidence for treatment 1, right? Okay, but is there a chance that more women could be here? Yes. So then we don't know. We don't know, did the response actually happen because of the treatment? So right? So Y, X causes Y. Did Y actually happen because of the treatment, or did it happen because there was more women in group 1? And that's a lurking variable right there. And what we say with a lurking variable is we say that a lurking variable is confounded with the explanatory variable if we don't know if Y was the result from X or if Y was the result from Z. If you can't tell the difference, then it's called confounded, okay? I know this was the very first thing we did in the entire year, and you don't come back to it a whole lot. So are there any questions right now? My notes aren't super fancy here. It's just kind of explaining. We're good? Okay, let's go back to those terms, and then we're going to do just a couple problems together. Okay, so we talked about simple random sample versus a stratified random sample. Completely randomized was that second one versus the block design. Let's actually talk about a cluster sample. Do you guys remember what a cluster sample is? Okay, for those of you who have me, it's your day 12, I think, free response question that I'm giving you. But what a cluster sample, the easiest way to understand it for you guys would be, let's say I don't have the time or the money to do a simple random sample where I get a list of every single student in the school. Yes. Is there what? Say that again, Eric. I'm sorry. It's a little more convenient, but it's not as biased as a convenient sample. So let me actually put it like those of you who are visual. So a cluster sample is, let's go back to that pizza question. Okay, yep, question. Yes, this is the advisories. Okay, so let's just kind of talk about the pros and the cons. So I still am wondering what everyone's favorite pizza is, right? Okay. Or I'm wondering, what percent that's their favorite pizza. Who loves pizza here? Okay. So I don't want to take the time or the money. It costs a lot of money and time, right? Time is money to get a whole list of the school, look at their ID numbers, and randomly generate numbers to figure out if they love pizza or not. I don't want to do that. Okay. I also don't want to do a stratified random sample because then I have to break it up by 9th grade, 10th grade, 11th grade, 12th grade. That takes even more time. So a way to still do this in like a legitimate way to get data without it being too biased would be a cluster sample. And what would be easiest for me to do would to be get a list of all advisories. I have no idea how many advisories there are, but let's just pretend that there's a total of 650, perfect. 50 advisories, okay? And we know there's approximately 15 kids in each advisory. So let's say that we want 10 advisories. So what would happen then is we would label all the advisors, right? Or the AP exam accepts the HAT method, and I always encourage my kids to do that. So how would I describe the HAT method on the AP exam? I'd say on separate sheets of paper that are what? Identical, that are identical. I'd write the names of all the teachers on those separate sheets of papers. I put them in a hat. I mix it up. And don't forget to mix it up because what is mixing it up doing? Randomization. And then I pull out the 10 advisors. And then once I get those 10 advisors, who is interviewed? All the students on that advisory. Okay, so that's a cluster sample there. I really encourage you to use the HAT method whenever you're describing how to use randomization. Go back to Hunger Games. They use the HAT method. If it's blocked, how many hats? Do you need 2 hats, 1 hat, 3 hats? And same size sheet of paper, mix it up, pull out how many you need. Yes. That will be for a free response question. Okay, that will be a free response question. They won't put HAT method in like the actual multiple choice part, I'm guessing. Yes.
How are the tests formatted?
So you'll have 40 multiple choice questions first. Okay. You'll get 90 minutes for it. So approximately 2 minutes per question, right? And then you'll have your free response questions, which are 6, and you'll get 90 minutes for that as well. Okay. And remember how long you should spend on the first 5 questions?
10 minutes?
Approximately 10 minutes. And then the last question is a 30-minuter. Okay.
How many points? Are they all weighted equally?
The number 6 one is weighted a little bit more. Okay.
What are the multiple choice and free response rated the same?
Yes. Well, yes. And I'll give that to you guys in class, how it's actually broken down. That'll be one of our days. I would love to do a practice test in class, but I've more been trying to just do like the 10 questions at a time. Would you guys want to do a practice test in class?
Try that in class, but like, yeah, I would.
You'd like to do it in class?
Yeah.
Yep, we can do it in class. That's fine. I've been trying to just do like the 10 questions at a time. But if you think it'd be more beneficial to do all of them at once, sure, we can do that. Huh? You'd rather do that?
I personally would rather.
That's fine. We can do that. It's kind of like I have kind of a set of what we need to do, but some of you, I've only taught AP stats where you guys have taken a lot of AP classes. So sometimes you know what works more for you personally. And yeah, I'm flexible. So
I feel like if we do the whole test at once, we can get a sense of the time too.
that's true. That's true.
Yeah, but you could.
We could maybe,
You could see how long it took you to do however many questions you did.
that's true.
At your pace.
That's true. Yeah. So, all right, I'm going to move on unless there's other questions. Okay. I think we got almost everything on this page here.
I think I have a question.
Yeah, what's up?
When are you gonna do the thing where you teach us how to become one with our calculator?
That will be one of the days either this week or next week. So, yeah, we do need to become one with the calculator. So, convenience sample, do you guys know what that is?
Yes, yeah.
Convenience sample would be like if I go to the mall and start asking people questions. Yep.
If you go to the mall and then like flip a coin for every person that comes,
Yep.
is that still a convenience sample?
It's still a convenience sample, so it still is biased. There's some randomization in there at least, but it's still not a good method.
Because like there was a problem on that in one of our not on a test but one of our forums that like they went outside and they watched every car like for every like they're saying red cars sped more.
Right,
And
right,
every car that would come, they flip a coin, and if it was like heads, they would do the test. Tails, they would let it pass.
right.
Would that be a convenience sample?
That's still a convenience sample. Yeah.
So it's
Yeah.
invalid.
Well, it's not necessarily invalid. It's the same when I was talking today about getting volunteers in a medical study. You know, you're not going to just go to the whole world and say, "All right, I called." It's not like jury duty. You know what I mean? Like you have to be part of this. You have to volunteer. So it's just something that statisticians do later in like a write up. Like, okay, well, we did get no, a convenience sample I would for sure. I don't think that's valid, but when it comes to volunteers, you'd write that up. You know, these are volunteers. So and so on. Yeah.
Then wouldn't necessarily like every sample or like SRS be a convenience sample? Like let's say your example like Armstrong.
It depends on what the population is, right? So like if we're trying to draw conclusions about Armstrong, then it's okay, right? We're just taking a sample of Armstrong students to draw conclusions about it. The state of Minnesota sometimes has given surveys and they tell high schools you need to do, you know, they pick certain high schools. You got called and your high school, you're part of our sample size. So, you know, there's pluses and minuses, and that's what some people don't like about statistics because it's not always physics. It's not a precise thing. Yeah, right. I mean, it is sometimes. So, um, but you know, as you get more advanced, there's more advanced methods of making sure that we really are representative of what the population is. So, any other questions? All right, let's talk quickly about some biases. Non-response bias. You know what non-response bias is?
Call someone on the phone and they don't answer.
Yes, you don't answer. People just choose not to respond. Voluntary response. What is that? Yeah, like you go online, right? And you really want to do the survey. So you're volunteering or you might get something like your parents might get some oh, for example, my son goes to RSI and we an email link was I'm not talking right. A link was emailed to us where I could respond what I thought of the school, right? And I did it because mainly because I'm a stats teacher, so I know like I love RSI, but I'm not, you know, I'm not a person that's always going to voice my opinion one way or the other. I'm not upset with RSI, but usually what happens is people who are upset or who really love it will respond. So it's hard to really gauge what people are thinking. You know, sometimes teachers will say, "Oh my gosh, it just wasn't a great day in class today." And then they'll start like dissecting it with their colleagues. And then all of a sudden you start to realize, like if it's you that said that, oh, it really was only three people that were saying they didn't get it. But people who don't get it or people who are upset usually are the loudest people, right? It's the people who get it aren't saying, Miss Opal, I get it. It's wonderful. It's the people who don't get it, right? So people who are emotional, they respond to things. And that's why a voluntary response sample is not good. How about under coverage? How are we doing there? That's fine. Under coverage would be like if I took a phone book. I don't, do they even make phone books anymore? I take the yellow pages online and I grabbed everyone's house phone number and then put them in a hat, pulled them out and started calling your house on identical sheets of paper, mixed up. But what would that be then? Who am I missing out if I just take people's house phones? People who don't have cell phones. Okay, so under coverage is where we're missing a certain population of people. Wording is one of the biggest influencers. That's not a word. Influences on how people respond to a question. If you come home late and your mom says to you, "Where were you? Why are you late?" versus "You were out making bad choices, weren't you?" You respond differently to your parents the way they ask you things. Okay. You want to stay away from words that kind of get emotion. So, do you really think study hall is an effective way to do homework and get all your stuff done? Or would you rather have open lunch, which guarantees all these freedoms? Okay, so when you use those kind of words, that influences you. Whether if you just said, would you rather have a study hall or open lunch? Okay, you take the emotion out of it. Questions on wording?
This is when
Yeah.
like first semester.
Yep.
And the problem is like it was talking about whether the Second Amendment, like talking about
Yes, there was one about that. Yeah.
talking about like whether it should be a thing because it's like a constitutional right.
Yes.
Like
Yes.
that is a leading
That's a
question.
wording one. It's not necessarily leading questions are okay. It's okay to ask someone like a yes or no question, but Eric's talking about one of the first tests we had where there's a question about your constitutional right to bear arms. And it had some more on there, but because they said something of constitutional rights, people are more likely going to respond to, well, I don't want my rights to be taken away. Whereas if you just talked about gun control in general without saying, do you think it's okay to take your rights away? You know, no one wants their rights taken away from them. So it was the way the word was phrased there. That's why the wording was biased. Okay. Questions? All right, matched pairs. We just talked about this in my class. What's the big thing with matched pairs? How do you know something's matched pairs?
Everyone's given two treatments.
Not always, but most likely everyone's given two treatments. There was a multiple choice question I gave where they had seeds. Well, you can't give a seed two treatments. So what they gave the two treatments to was the jar that the seeds were in. Do you remember that? Yeah. Yeah, so there can be, and Mr. Jans and I talked about this a little bit. We really haven't seen this a whole lot on the test. It's more about getting the two treatments. There can be a time where, um, let's say Nike is testing out a new shoe, okay? And Nike is going to talk to marathon runners, and they want marathon runners to train or to run in these new shoes. Well, a marathon runner is not going to want to do one shoe with a certain sole and another shoe with a certain sole. That's going to get them off with their running. So what they'll do is they'll find, so like for example, it was me, they'd find someone of my height, my weight, and my running style. And I would be matched up with that person. So I might have one form of Nike shoe and they have the other form of Nike shoe. And then after they look at like the tread on the shoe and how much is it worn down because I can't wear both shoes. That just doesn't make sense. But I did do a problem in my class where it was a boot spray, and I talked about Uggs came up with a new spray. Well, I don't want to give Danny the old spray and Eric the new spray because Danny might go outside a lot more than Eric, right? So then all of a sudden we have these lurking variables. So instead, I give Danny a spray for one of his shoes and the other spray for the other shoes, so he gets the two treatments. We see that more often than we do where they actually match you up with someone. Okay, question? Yep. Okay, so yeah, I gave one today or a couple days ago, and people thought it was a chi-square. So is that your kind of your question? Like, how do you keep them separate? The biggest thing with chi-square is chi-square is really dealing with an observation. It's not dealing with an experiment. So in chi-square, for example, like the M&Ms, we might be trying to see if my package of M&Ms fits the percentage of what the Mars candy bar says. So in a goodness of fit, so I'll write this down. In a goodness of fit, we have a distribution that actually happened, right? So we have blue, red, orange, right? And we got 10, 12, 8. Okay. So again, this is an observation here. This is not an experiment. Where a matched pairs is most likely an experiment, right? You get both treatments. And then just to kind of piggyback off that, for a goodness of fit, I have one sample and one variable I'm looking at. Okay, I'm looking at the color. I have one sample of my M&Ms, and then what should happen? Well, Mars will come out and they'll say, well, 60% should be blue and 20% should be red and 20% should be orange. And then we take the total sample that we have and multiply it by these percentages. And we examine if there's any big differences. Okay. Do you want me to keep talking about chi-square since we're on that right now? Okay, so chi-square for independence, again, this is okay, so for chi-square for independence, this would be if I had a two-way table and you have one sample and two variables. So an example of this would be a sample survey where I would give you something where you have to check the box, right? And you would say your gender, and then maybe what college you're going to. Like if you're going to a 4-year school or you're going to a 2-year school, right? So in my box here, I would have male, I'd have female, and then I'd have, I'd have 4-year, I'd have 4-year and then 2-year. I have my one sample, I have two variables, and I want to see if gender is independent of what kind of college you go to, okay? And then finally, you would have your chi-square for homogeneity. And this is where you have 2 plus samples, and then you have one variable. Okay, so an example here would be, let's say Mrs. Blow wants to look at her calculus exams for the last like 3 years. So she could have the year 2013, 2014, and 2015. And she wants to look at the distributions of 5, 4, and 3. And she wants to ask the question, are the distributions of who got a 5, 4, and 3 the same across the last 3 years? The counts could be different. I could have 10 here, 12 here, 13 here. That doesn't mean anything because it's all based off of the total size, right? So she would want to investigate, are these distributions the same or not? Yeah.
Are we gonna be doing like what are we doing after the AP test? Are we gonna be like doing
We'll talk about that later.
yeah,
Let's
that's gonna be so cool.
oh, to like actually do. Yeah, we have something planned for that. So yeah, that is kind of we do. Yeah. Okay, I want to just we've been going for 30 minutes. So I just kind of want to give you a preview of like what else is on the site, and then I'm just gonna finish this up tomorrow and then also Thursday after school. So tomorrow, then you can kind of know, and then I'll have videos over it too. I have a couple problems. Do you guys want to do these problems quick before we go that have to deal with those? So let's do that, and then we can finish sampling and kind of clean that up. And then tomorrow I'll start probability. Does that sound okay? All right, so number 6, I'll read through it with you. A local television, and these all come from released exams. So these were actual AP problems. I've looked at a lot of released exams. There's the 2002, there's the 2007, 2012, and the 2016, as well as the practice one that they give. And a lot of these questions overlap. So a local television news station includes a viewer survey question about a current issue at the beginning of every evening news broadcast. Viewers are invited to use social media to respond to the question. The results of the survey are shared with the audience at the end of each broadcast. In relation to the opinions of the population of the region, which of the following is a possible reason why the results of such surveys could be biased? 1. Viewers with strong opinions about the current issue are more likely to respond than other viewers without strong opinions. Is that an issue? Yes, okay. Number 2, the opinions of viewers of one television station are not necessarily representative of the population of a region. Yes, definitely, right? And then viewers with access to social media are not necessarily representative of the population of the region. Yes, so the correct answer is E. So here's a typical kind of question that you might see over sampling. Questions there. Right, or sampling experimentation and what kind of comes with this. This all falls under the realm of topic 2. Okay, number 38. A newspaper editor wants to investigate whether residents of the city support a proposal to build a new high school football stadium. The editor hires a polling firm to conduct a survey and requests that a sample of 500 residents be selected using a stratified sampling design based on voting districts within the city, right? So we all live in different voting districts. How do we know that? Because we go, like I go to the Crystal Police Department. Your parents might come to Armstrong. You know, there's different places that you go to vote. So they'll look at those districts, right? And those would be our hats if we were going to actually describe it. All right, so which of the following methods will achieve the desired sampling design? A, send a survey to all residents and use the first 500 returned surveys for the sample. No. That would be, I think, I would probably call that a systematic sample. So a systematic sample is where you just decide, this is the system I'm going to use. So for example, one would be, some people actually do this. They'll stand at like the football gate and they'll interview every 10th person that comes into the football stadium and ask them a question. Or I'm going to interview every third person in my class based off the roster. So some sort of system for getting some data. Does that make sense?
Wouldn't that also kind of be a convenience sample?
Yeah, exactly. And it's not an okay. It's not legitimate. Okay. Part B. Select a random sample from each voting district based on the proportion of city residents in the district so that a total of 500 is obtained. Okay, so let's read through that slower. Select a random sample from each voting district based on the proportion. Now, why did they say that?
So you get it. So like if there's 50 in this district and 10 in the other, you take like 5.
Exactly. So it's proportional. Okay, so like if here's my voting districts, and I have 50 people here and only 10 people here, I don't want to interview 2 and 2 necessarily, right? That's not proportional. That's not necessarily representative of everyone. So I would interview 5 people from A and 1 person from B. Does that make sense? Okay, so right away, you can see that B is most likely going to be the answer. You can cruise through the other ones and read them if you'd like, but because of time, I'm not going to do that. And B is the right answer. Okay. Other questions there? And I know your handout's really little. I'm sorry. I was just trying to save some paper. Okay, let's go through the next one then that I have planned. Number 18. Researchers want to investigate whether babies have a sense of right and wrong. They showed each of 60 babies a puppet in which a red puppet was trying to open a heavy box lid. A second puppet called the helper would try to, now this is a lot of words. So what would you do if you were, do I dare tell you to look outside right now, you guys, on May 1st, 2017? No, I just can't believe it's snowing. Okay. All right. That's nuts. Okay, so reachers. Okay, so a lot of words, guys. What's a test taking strategy that you would do here?
Look at the question and come back and figure it out.
Sure, you could look at the question. I would also start. We know that it's probably going to be a sampling question here, or it could be some sort of confidence interval or test. So, 60 babies at a puppet show. There's a red puppet trying to open a heavy box. There's a second puppet called the helper, which would try to help the red puppet open the box, while a third puppet called the hinderer would try to slam the box lid down. After watching the after watching the show, each baby was presented with a tray containing the helper puppet and the hinderer puppet, and the researchers recorded which puppet the baby reached for. The researchers wanted to determine, now here's the question they're asking, whether the babies would reach for the helper puppet more than for the hinderer puppet. As part of the show, a green puppet and a yellow puppet served as the helper and the hinderer. For each baby, a coin was tossed. Okay, that's important. There's your randomization to determine which color would serve which role. Which of the following is the most important reason for the random assignment of color to role in this study? Okay. A, slamming the lid might cause wear on the hinderer's puppet after 60 shows. Okay, so if you can kind of laugh at one right away, you probably know what. It's not, yeah, it's not it. All right. Yeah. Okay, the puppeteer might grow tired of doing the same show with the same puppet colors. All right. If the same role is played by the same color puppet, the baby might show preference for the color instead of, there you go, okay, instead of the preference for the role. Let's keep reading though. The random assignment of color to role allows the researchers to determine if one color is better than another in teaching babies right or wrong. No, I mean, it sounds a little more statistical, right, than just a kind of goofy answer, but um, boys and girls might prefer different colors. The random of assignment to color to role ensures that the show is equally accessible to boys and girls. Is this anything about boys and girls in there? No. So the answer is C.
Kind of a wordy question.
It is a very, very wordy question.
I don't really understand what just went on.
That was a very, very wordy question. Any questions about that one though? Other than it was really wordy. At least not all of them are that wordy. I think that's all I have then for those. Oh, one more?
There's 2 more.
Is there 2 more? Okay. A florist wanted to investigate whether a new powder added to the water of cut flowers helps to keep the flowers fresh longer than just water alone. For a shipment of roses that was delivered to the store, the florist flipped a coin. Okay, so there's your randomization before placing each rose in its own individual container with water. If the coin landed heads up, the rose was placed in a water with new powder. Otherwise, the rose was planted in water alone. Why did they do a water alone? Just to do like, yeah, your control, okay? Which of the following is the best description of the method used by the florist? A census, because all roses are assigned to a container. No, it's just a shipment and then, okay, so no. An experiment with a completely randomized design. An experiment with a block design with blocking by type of water. Do they say anything about a type of water? No. An experiment with a matched pairs design. Are they getting both treatments? No. An observational study. No, because an experiment imposes a treatment. An observational study, if you remember from first semester, I would say observe, don't disturb. Okay, so it's not an observational study. It is going to be an experiment with a completely randomized design. You just need to go back to that Hunger Games. Did all the roses come from one hat or did they come from 2? Okay, and they all came from the same box. As a result, we know it's a completely randomized design, which is similar to a stratified random sample if we were just doing sampling and not an experiment. All right, last one, and then let's go. You guys have been troopers here. Some contact lens wearers report problems with dryness in their eyes. A study was conducted to evaluate the effectiveness of new eye drop solution to relieve dryness for contact lens wearers. 25 volunteers who wore contact lens agreed to use the new solution for 1 month. Is this okay that they're volunteers?
Yes.
Yeah, it is okay. It's uncomfortable, but it's okay. Okay.
Why is it okay?
It's okay. In all medical studies or any kind, we need volunteers. Like I said before, I'm not going to just like everyone who wears contacts in the school, you have to be part of this study.
I know, but wasn't there something first semester about how if it's voluntary, then that's not random anymore?
No, so what you'll notice is they'll somehow they'll like randomly put them to the groups then. Because sometimes you might have volunteers, like I might say, hey guys, I think yoga really helps stress, but I also think napping really helps stress. So I'm going to let you guys decide. You can volunteer. Yep, I'll volunteer. Okay. And then let's say your friend volunteers too. And then I'm going to say, you get to choose which group you go in. Well, now all of a sudden there's no randomization there. So this is my little side note, right? I have my group of volunteers that are my students, and you get to choose. Do you want to do the yoga for stress relief or do you want to do a nap? And we're going to say that a nap wins out. Yay, naps are better for stress relief. But if you get to choose which group you're going to, now all of a sudden, I don't know if nap won because it actually is better for stress relief, or did you just go with all your friends, right? You chose the group, and maybe it was because you were with your friends that you like had less stress. So that's why we can use our volunteers here still, but then we have to put their names in a hat and randomly put them into what group they should be. It's not ideal to have volunteers, obviously, but it is okay. All right, let's go back to this here. So we have the volunteers who wear contact lenses agreed to use the new solution for 1 month. At the end of the month, 36% of the volunteers reported that the new solution was effective in relieving dryness. The company that produced the new eye drop solution concluded, okay, that using the new solution is more effective in relieving dryness than using no solution. What is the following best explanation for why the study does not support such conclusion? Right away, do you see what's wrong with it?
Yes.
What? Yes, the study had no control group. The only way we can draw conclusions, cause and effect, through a well-designed experiment with randomization, control, and using enough subjects.
What's enough again?
That would be our rule. What rule is it? Our normal rule. So n is greater than or equal to 30, okay? Or your NP rule.
Is it also, this didn't have any control, but it also didn't have any random.
You're right, because you all, like they all got the one solution.
Yeah. So wouldn't A also be correct?
No, that sample size is not too small. If you think about 25 volunteers, like when you do your rules, you can get it either where the distribution is going to be symmetric or 25 times the proportion will be greater than or equal to 10, right? So, yeah.
What's the thing where if it comes from a symmetric, like the subjects come from a symmetric population?
Then it doesn't matter the sample size.
I know, but what test is that for? Isn't that only for a certain one?
The t-test or the t-interval. I shouldn't say it doesn't matter the size, but yes. So our central limit theorem tells us that n has to be greater than or equal to 30. And so if it's between 15 and 30, right? Then we just need to make sure that it can be skewed, but there can't be any, like it can't be a super strong skew and there's no outliers. If it's less than 30, that should be an n, sorry. Less than 15, oh, it's the end, and so I'm messing up here, I'm sorry. Then if it comes from a normal population, it doesn't matter. We can use the normal model, okay, to draw conclusions. So then we don't even have to test any of this. So if it states it's normal, like you're good to go. You don't even have to talk about that. Any other?
For your independence condition, then you would just write comes from a normal population.
Exactly. Not for the independence condition, for the normal condition. Yep.
And then independence lets you use standard deviation.
Yes. Independence lets you use the standard deviation. Any other questions, guys? All right. Thanks for coming in, you guys. That was a good session.